One thing that visually impaired individuals can struggle with is recognizing something as simple as the color of their clothes. You see, my dad is blind and has no vision in one eye and 2400 vision in the other, meaning what you can see from 400 feet away, he has to be 20 feet away from. So he'll ask me, man, are these pants blue? Are they navy? Are they black? What color are they? My partner, Aaron Alley, and I, Austin Guillory, hope to change fashion for the visually impaired forever with our device, the ColorPal, in both a practical and affordable way. Light is affected by three factors: distance, ambient light, and the reflectiveness of the material. So what we were able to do is eliminate the factors of distance and ambient light by ensuring that the distance measured is the exact same every time and all ambient light is blocked out. The way that the sensor functions is by reading the RGB, the red, green, and blue values of whatever material you are testing. These pulse values are then translated into true RGB values, which are then translated into colors based on predefined ranges within the code. These color names are then sent to the text-to-speech module, which translates this text into a sound wave. This sound wave is outputted through a speaker that was implemented on the device. For added convenience, the backing is magnetically mounted, allowing ease of use with replacing the battery and accessing the internals of the device. Additional accessibility features were added, that being a tactile power button as well as an auditory startup cue.
This one?
Yep. Red.
Okay. Wow, that's pretty speedy.
Yes. Orange.
Mm-hmm.
Yellow.
I think clothing identification would be, for me personally, a top priority. I also think it is helpful for identifying art supplies, paper, different colors of paper, for example. Lots of different applications, but I think the primary one would be for clothing. The system worked great. It was very user-friendly and intuitive and very responsive, so it performed flawlessly. I like the fact that the sensor is protected so that it minimizes the light, because that can change the way it reads the color. I would say just one thing is to, for example, if you had like plum and lavender or something, would it determine between like shades of a color? I think that it's as simple as the concept sounds. There are a few color identifiers on the market, but the options are very limited and they can be more cost prohibitive. I think this system responds quickly, and so that's very helpful. And what I appreciate about this system is that it is a true need, you know, for someone who's blind to be able to determine what color something is quickly and efficiently. And so having a very simple, straightforward color identifier that's reliable is a really useful tool.
This project brings together multiple engineering disciplines to create a user-friendly device. Electrical engineering is used in powering the device, used in the wiring of the color sensor, the text-to-speech sensor, and the speaker, which are all soldered together to create a functional device. Computer and software engineering play a key role in the coding of the project. The color sensor had to be calibrated to its specific values in order to give an accurate reading. Mechanical engineering is used in the 3D modeling of the project. The project had to be put into SolidWorks and created so that it could be printed accurately to the design that it is now. Systems engineering ties everything together, ensuring the seamless integration of all the parts, optimizing the user experience, and balancing the cost to make it a cost-friendly product. Ultimately, we feel we have achieved our goal of making this common problem of color recognition for the visually impaired more accurate and more affordable.